Children on Yoshima, a remote island in the Seto Inland Sea, were given strand fixing plates to write their commemorative signatures on. The 271st strand, the last, is pulled out. The visions of the Yoshima Island children are now firmly anchored. May 1986, a Kitamai Bune, a replica of the ships that once plied the waters from the vital Seto inland seaports to as far north as Hokkaido, set sail once again. Such transportation ships were a major factor in the prosperity of the Seto inland sea port towns. At that time, famous actors of the leading theatrical troupes gathered from around the country to give performances in front of Kompira Shrine. Their brilliant performances were reenacted for the upcoming completion of the Seto Ohashi Bridge. The Kanamaruza Theater, Japan's oldest. With such festivities held to revitalize the old townships, the Seto Ohashi Bridge is coming to the final and most important stage. Installing the hanger cables to suspend the bridge girders. Suspension bridges support massive weight within the limits of volume and kind of materials used. How can such a large and long suspension bridge withstand storms and typhoons? Attention is focused on the girders. Wind tunnel testing began 15 years before the start of construction. With the disastrous collapse of the Tacoma Narrows Bridge as a turning point, wind tunnel testing became an indispensable process in designing suspension bridges. Bridge girders absorb wind energies, even when they have good air ventilation. This is because of the dangerous phenomenon of vibration increasing in intensity, known as self-excited vibration. This self-excited vibration increases infinitely and can destroy bridges in a relatively short period. It was this vibration that contributed to the collapse of the Tacoma Narrows Bridge. But how to cope with such wind forces? The central part of a bridge girder is provided with openings so that winds can blow through vertically. Vibration is then greatly reduced. Through repeated elaborate wind tunnel testing, the so far unknown world of winds and girders is gradually being revealed. The results of wind tunnel testing were put to practical tests in the real world. Testing is repeated to verify girder resistance to the 65 meters a second wind velocity storms that the Seto Ohashi Bridge might be subjected to during the 100 years to come. Bridge girder behavior and resistance to winds undergoes delicate changes, even with a minute change in the form of the railings. To reconfirm the safety of the girders, experiments were conducted repeatedly up to the very last moment of construction. August 1986. The girders were completed after a full 20 years of determined efforts in the fight against winds. The bridge construction operations now approaches its crowning moment. All the staff were mobilized to prepare for the operation to take place the next morning. Each person's role is reaffirmed. They wait for the signal. The wind rose. The operation postponed. The next morning, the staff gathers again. At daybreak, the wind subsides. This girder is to be installed 90 meters above sea level. The hanger cables were temporarily pulled back to make room for the floating cranes. Taking into account the changes in sea level just before flood tide, the floating cranes were moved forward slowly. As the enormous girder comes just below the cables, it is lifted to a height of 90 meters in accordance with the data coming from the monitoring team. Then, inch by inch, it is moved horizontally nearer to the towers. Now, the most critical stage. 2 more meters to go. The hanger cables are then locked into place. A giant block of steel suspended 90 meters above sea level. It's a now or never moment. All the 6 joints must register perfectly and simultaneously, or there is no jointing at all. The floating cranes prevent views of the operation. If the girder collides at the joints, it must be remade. Tensions build. "50 centimeters to go." Once again, success has been achieved on a tremendous scale. From production in factories on land to installation over the sea, girder installation now moves on to the next phase. The central part of the bridge overhangs the international sea lane, so the girders were made into blocks convenient for hauling. An array of large installation equipment on the girders. All the equipment together weighs 10,000 tons. About 250 workers were necessary to operate the installation equipment. Grated floors. The railroad grated floor construction allows wind to pass through, except for the narrow parts to lay the rails on. The new road now reveals its full length over the sea, with the distant sound of waves in the Bisan Seto Narrows echoing in the background. Towering 190 meters above sea level and plunging 50 meters down to bedrock, the Seto Ohashi Bridge creates a masterpiece of magnificent, formative art. The Seto Inland Sea is about to see the birth of a structure created not only by benefiting from data available in the world's bridge construction technology, but also by developing and refining this superb technology even more. April 1987, the 9th year since the start of construction. The first crossing of the Shimotsui Seto section. July 19th, the joining of the central parts of the Minami Bisan Seto section. The linking of Honshu and Shikoku Islands, a historic day of overwhelming significance. With Hokkaido and Honshu and Kyushu already connected by railway tunnels, the four main islands of the Japanese archipelago are about to be solidly interlinked.
原山さん、水木さん、なんぼ縮んだか、記録しとってください、どうぞ。
The jacks used to expand the central part of the girder are being removed, proclaiming the start of the bridge jointing operation.
No.
January 1988. Bridge vibration testing was carried out once again to check if the countermeasures for earthquakes and winds have been completed as designed. Train trafficability tests. Massive locomotives in a 13-car formation make a test run from the Honshu side to Shikoku. The train weighs 1,027 tons, a weight used for such a long bridge for the first time in history. Just as designed, the bridge responds flexibly to the weight of the running train. Voyage of the Uno to Takamatsu ferry, until now the only means of transportation between Honshu and Shikoku. More than a century had passed since the day when a troupe of Japanese acrobats first saw the magnificent Brooklyn Bridge in New York City. Vision and dedicated enthusiasm of a countless number of people has culminated in a long-awaited bridge. Construction technology embodying the genius of an American father and son inspired Japanese engineers to develop it further through times of storm and stress to result in the creation of the Seto Ohashi Bridge. The dedication, wisdom, and enthusiasm that have gone into making the bridge will again cross national boundaries to create bridges that will strengthen the ties between peoples around the world and give them dreams and courage for a brighter, richer future.